Hi friends. Here, the question is a man can send an email on average 2 emails per hour. What is the probability that the man sends more than 3 emails in 2 hours? We know that the Poisson probability formula is P of x equal to e raised to minus lambda into lambda raised to x divided by x factorial. Now we have to find out the lambda, the parameter of the Poisson distribution in 2 hours. Let x be the number of emails in 2 hours. Because we have to find out the probability that the man sends more than 3 emails in 2 hours. Given that the average rate of emails per hour is 2, that is 2 emails in 1 hour. Now we have to find out the number of emails in 2 hours implies lambda equal to 2 by 1 into 2 equal to 4. Therefore, the average rate of emails in 2 hours is 4. That is, the Poisson probability formula is P of x equal to e raised to minus 4 into 4 raised to x divided by x factorial. Now we have to find out the probability of man sends more than 3 emails in 2 hours. That is P of x greater than 3 equal to 1 minus P of x less than or equal to 3 equal to 1 minus P of x equal to 0 plus P of x equal to 1 plus P of x equal to 2 plus P of x equal to 3 equal to 1 minus e raised to minus 4 into 4 raised to 0 divided by 0 factorial plus P of x equal to 1 is e raised to minus 4 into 4 raised to 1 divided by 1 factorial plus P of x equal to 2 is e raised to minus 4 into 4 square divided by 2 factorial plus P of x equal to 3 is e raised to minus 4 into 4 cube divided by 3 factorial equal to 1 minus e raised to minus 4 is 0.0183156 into 4 raised to 0 is 1 divided by 0 factorial is 1 plus e raised to minus 4 is 0.0183156 into 4 raised to 1 is 4 divided by 1 factorial is 1 plus e raised to minus 4 is 0.0183156 into 4 square is 16 divided by 2 factorial is 2 plus e raised to minus 4 is 0.0183156 into 4 cube is 64 divided by 3 factorial is 6 equal to 1 minus 0.018315 plus 0.018315 into 4 divided by 1 is 0.07326 plus 0.0183156 into 16 by 2 is 0.146525 plus 0.183156 into 64 divided by 6 is 0.195366805. Now 1 minus 0.018356 plus 0.073263 plus 0.1465625 plus 0.195366 is calculated as 0.56653. It is approximately equal to 0.5665. Here, the question is, patients arrive at a hospital accident and emergency department at random at a rate of 4 per hour. A patient arrives at 1 a.m. Find the probability that the next patient arrives before 1:15 a.m. That is, we have to find out the probability of next patient arrive after 15 minutes. Therefore, let X be the number of patients arrive in 15 minutes. We have to find out the average rate of patients arrive 15 minutes, given that the 4 patients arrive per hour. Per hour means 60 minutes. That is, 4 patients arrive per 60 minutes. Now we have to find out the number of patients arrive at 15 minutes. Implies lambda equal to 4 by 60 into 50 equal to 1. That is, the average rate of patients arrive at 15 minutes is 1. Then the Poisson formula is P of x equal to e raised to minus lambda into lambda raised to x divided by x factorial equal to, here given that lambda equal to 1. Therefore, e raised to minus 1 into 1 raised to x divided by x factorial. Now, we have to find out the probability that the next patient arrives before 1:15 a.m. is P of x greater than or equal to 1 equal to 1 minus P of x less than 1 equal to 1 minus P of x equal to 0 equal to 1 minus e raised to minus 1 into 1 raised to 0 divided by 0 factorial equal to 1 minus e raised to minus 1 is 0.367879441 into 1 raised to 0 is 1, 0 factorial is 1 equal to 1 minus 0.367879441. It is calculated as 0.6321205558 and it is approximately equal to 0.6321. Here, the question is, a manufacturer produces light bulbs that are packed into boxes of 100. If quality control studies indicate that 0.5% of the light bulbs produced are defective, what percentage of boxes will contain no defective, one or more defective? We know that when the number of trials becomes large and the probability of success becomes very small, we use Poisson approximation to the binomial probability distribution. Here, the number of light bulbs are 100 and the probability of light bulbs are defective is 0.5%. It is 0.005. That is, the number of light bulbs are very large and the probabilities of light bulbs are defective is very small. So here we use Poisson approximation to the binomial probability distribution. The Poisson formula is P of x equal to e raised to minus lambda into lambda raised to x divided by x factorial. Now we have to find out lambda, the parameter of the Poisson distribution. When we use Poisson approximation to the binomial probability distribution, lambda is calculated as n into p. N is the number of trials, that is the number of light bulbs. Here, number of light bulbs is 100. P is the probability of success, that is probability of light bulbs produced are defective. Here, probability of light bulbs produced are defective is 0.005 equal to 0.5. That is, the parameter of the Poisson distribution is lambda equal to 0.5. Now, we have to find out there is no defective light bulbs are produced. That is, P of x equal to 0 equal to e raised to minus 0.5 into 0.5 raised to 0 divided by 0 factorial equal to e raised to minus 0.5 is 0.606530659 into 0.5 raised to 0 is 1 divided by 0 factorial is 1 equal to 0.606530659. It is approximately equal to 0.6065. Now we have to find out probability of one or more defective light bulbs, that is P of x greater than or equal to 1 equal to 1 minus P of x less than 1 equal to 1 minus P of x equal to 0 equal to, from the above problem, P of x equal to 0 is 0.606530659. That is equal to 0.393469341. It is approximately equal to 0.3935. Thank you.